Okay, good afternoon to everyone. And today we are doing this JetBrains research seminar on control systems and integration of different systems with our new development. It's Magix. It is combined development by the people from DESY, JetBrains research, and other contributors as well. And the first talk today will be by Vasily Kuporosov from High School of Economics in St. Petersburg, and he will talk about integration of Magix API with a DOOCS client. And the second talk will be by Igor Khokhriakov, who will talk about integration with the Tango-Controls. So if you have any question, please ask them during the talk. And if they are long, we will move them to the discussion after the talk, but you can ask anyway. And so, Vasily, please start.
Hello, can you hear me?
Yeah, a little bit. You can, if you could increase the volume a bit, it will be nice.
Unfortunately, I can't.
Okay,
I
it's
can
fine.
try just speaking
Okay, it's fine.
louder.
It's fine.
So I will share my screen. Can you see the presentation?
Yeah, it's fine.
All right. So hello, my name is Vasily Kuporosov. I'm a 6-year student in the High School of Economics in St. Petersburg, and I will tell you about my work on Magix DOOCS connector. So first I will describe in short what DOOCS is. It is a distributed object-oriented control system. It consists of many devices and servers, and so to locate each server and property, it has a 4-layered namespace. So the first 2 layers are facility and device. They represent the real server process to which we connect. Location is just a set of properties, and the last layer is property, and so we can access them from a client, and we can get them or set. So get only gets the current value of a property, and set modifies the property. So yeah, DOOCS also has a library that helps programmers implement client applications, and those client applications can access the servers and get and set properties. For that, they need an echo address that specifies the address that has a 4-layered structure, as I have already mentioned. Then it makes an echo call. It is an object that represents get or set call, and echo data is a data structure that actually stores the parameters of those calls and the results. So what is the structure of echo data? It consists of several properties. Here are here are the 2 properties that are highlighted in red. They are type ID and value. These are the necessary properties. So type ID says what type of value is stored, and value is actually the value. All other fields are optional, so they can be omitted. Then how can we now I will describe what Magix is. Actually, it is an event loop that allows a client subscribe to it and receive all the messages that are in that loop, and a client can also broadcast a message, so it sends a message to the loop, and all other clients that have subscribed to that kind of message receive them. Yeah, so a Magix message, it can be in various formats, but now we're using JSON format, and it also has some fields. The only field that is necessary is origin, so who has sent this message. And one more interesting for us field is payload, because it actually stores the interesting information in that message. So how can we integrate DOOCS server with an event loop? To do that, we need a client, a special mediator that will subscribe to the event loop, receive messages from it, make get and set calls to a DOOCS server, will take the result and send it back to the event loop. Here it is important that in this part of the picture between event loop and DOOCS client, the data is transmitted via JSON, and here between client and server, it is echo data. So we need to somehow transform between these two types of information. So let's describe the JSON structure. It has also some fields, an action, so whether we want to get or set a property, the echo address of the server, and echo data. And here we take all the fields from DOOCS echo data and put them into JSON. And here we need to somehow encode the value depending on the type of that value. So let's look what types can be there. So echo data has several scalar types. They are bool, various integer types, and float and double. And all these scalar types have also vector versions. So these are arrays and these are scalars. So these scalars are stored in JSON as values. So the integers as integers, floats are as floating point values, and Boolean is stored in JSON as true or false, but in DOOCS it is stored as an integer field. So we also need to take this into consideration. And here all the vector types are stored in JSON like normal JSON arrays with those values inside. DOOCS also has string types. The first two types are different according to their length. So text can have any length, and data string, its length is limited. And there is one more string type, USTR. It has some extra fields that can hold some extra information. So I1 for int, F1 and 2 for float, also timestamp, it is also int, and the data, it is the actual string. And there is also a data A USTRs, so it is an array of USTRs. So when we have implemented this converter, we need to test it because there are very many cases that can and things that can go wrong. So we need to implement some strong tests. So first of all, we will test how our types convert to each other. So for each echo data type, we create a JSON with a value of that type. Then we convert it to into JSON. Then we we convert that JSON into echo data. Then we make the reverse conversion, so we get another JSON. And finally, we check that the resulting JSON is equal to the initial one, so that after the two conversions, we don't have lost anything. The second type of testing is an integration testing. So I have implemented a DOOCS server that has many properties. one property of each type that I have mentioned before. Then on the client side, I will, for each of those properties, I make a get call and check that I receive the data that I expect. After that, I make a set call. So I set another value, and I make a get call again and check that the new value that is returned from server now is an updated value. So that our set command has worked properly. After that, when we have the converter implemented, we need to integrate our client application with the event loop. So currently we are using ZeroMQ message broker for the event loop implementation. And here is a simple algorithm how our client integrates with ZeroMQ. So we subscribe to a ZeroMQ service. Then we start getting messages. When we get a message, we convert the query data into echo data. Then we make an echo call. Then we receive the response from DOOCS server and convert it back to JSON and send a message with that JSON back into the ZeroMQ. So as a conclusion, I will repeat what has been done. I have implemented a converter between Magix messages and DOOCS echo data. Then I provided a pack of tests that covers all types of all implemented data types. And finally, I have implemented a client application that communicates with ZeroMQ. And so now we can send a message into ZeroMQ, and after all this work, we will get back the response from DOOCS server. That's it. That's all that I wanted to tell you. Do you have any questions?
Yeah, thank you, Vasily. It was very good and very how is it, compact, which is nice. And please ask any questions if you have. Meanwhile, I've posted a link to the current version of specification of Magix DOOCS interoperability protocol, and I've also opened the actual code which is used. It's not finished yet because we need to write a README and some other things, but otherwise it's a working solution in a GitHub. Please follow the link if you want to look at it. And are there any questions?
So just, hi Vasily, just a question from my side. How long did it take for you to implement this?
It took me about 3 or 4 weeks, but I have worked for about a day or two a week, one working day.
Yeah, so it's impressive. Did you miss something from the DOOCS side? More documentation, or was it clear on your side? Or
Yeah, I know that DOOCS has a very, very good documentation, but not everything is. I couldn't find everything I needed there, so I had to look into the client lib and server lib code, and from that code I have found everything that I needed, and I have also found a bug there. I have reported it to a DOOCS server lib team, and they have responded, and they said that they would discuss it and then work on it.
yeah, very impressive. Will you give a demo here?
Unfortunately, now I cannot do it.
It's not that easy because you it's not that easy to set up it set it
No,
up.
it was just a question. So
Yeah, I believe that tests are already in repository, Vasily.
Yeah.
I see some tests, and I think it's a final test. I'm not sure, but I think they are. Or it is still missing integration test. I'm not sure.
Yeah, there is a code. There is a client side of integration testing. I will put my server side code into that same repository as soon as possible, and after that there will be the completed pack of tests. But I have still no tests for 0MQ so far.
yeah,
Okay.
please let us know if you need help, when you need help, what kind of help you need.
All right.
Primary problems with DOOCS are one thing is a build because it's not very reliable. The first part of this work I've done, I did not manage to build it properly on my Ubuntu, but Vasily managed because he has a better knowledge of C++. And maybe the primary problem is that the source codes are not publicly accessible. So we need to use this VPN, and it is a pain to keep your code up to date with this remote code, which protected by the VPN and DESY access.
Yeah, right. But this is what we what we already discussed. The problem is when you really make it open, so you get everything from us, but when you really make it open to the world, then you have to give also support.
You can develop open source libraries without community. It's just does not work this way.
Yeah, okay, not a discussion for here.
Yeah, okay.
Yeah.
So, Vasily, thank you very much for your talk. And I think it was much faster.
Well, sorry, I have a small question.
Oh, okay.
I just wonder whether it's possible on the DOOCS client side and basically in the whole architecture to use some asynchronous API. I mean, when you do a call to a DOOCS, is it always synchronous, or so you wait in your connector to the response and then send it back, or is it managed somehow? Am I clear?
Yeah, the question is clear. Thank you for the question. I believe that equal calls are only synchronous, but I'm not quite sure because I haven't read the whole documentation yet.
I can answer this question. There is actually a additional method which was not covered by what we do right now with Vasily. It's monitor something, which allows to subscribe to some changes inside specific device of specific property with a specific device, and then it gives callbacks whenever the property is changing. It is not implemented yet, but it's more or less easy to add right now because we tested the primary thing, meaning the converter from this echo data to this JSON format. And of course, Magix side supports asynchronous communication. It's done for synchronous communication.
Okay, so basically we can push notifications or new updates from DOOCS directly to Magix.
Yes, we can send some kind of event which asks us to subscribe for specific property and then get updates. So it should be quite easy to add. We haven't focused on it, but it should be doable.
Okay, thank you, and very nice presentation.
Yep.
Thank you.
So, Igor, if you are ready, we can start the second part.
Yeah, let me just try to share my screen. A window, maybe. Well, I have this well-known problem with screen sharing. Let me just try to connect to Firefox.
And you should either use latest Chrome or latest Firefox, and it works. Works well on both.
Yeah, it worked for a while, and things seems to be not anymore. Okay, let me just try to rejoin and then try again.
Meanwhile, what Vasily did not tell, that we also plan to implement this similar functionality for DOOCS server, not a DOOCS client, but DOOCS server as well, so we can access Magix-based devices or even other control systems as though they are DOOCS devices from DOOCS. This is this is our initial goal, because we want to implement IAXO experiment detector control systems, integrate them into DOOCS with a minimal pain. That's the idea. So Igor, is sharing okay right now?
No, unfortunately no. Okay, let me then try to close the Chrome and restart everything right now.
Some bizarre Linux problem again.
So during this break, I can come. Oh, there he is. Then not.
Igor, we see the screen, but I'm not sure that we can hear you. We probably can't hear you because you entered in the presentation mode. It does not give a sound. Okay. Sven, I think you can ask while Igor tries to connect again.
Vasily, when you have the first version of your server, it doesn't matter how complicated it is or not, maybe we can set it up here to make it run just as an early test.
We can try.
Pardon me?
Yeah, by the way, I have tried to to make that integration testing through VPN, and it didn't work for set calls. And I have found an issue in DOOCS server lib that I believe concerns this issue. So yeah, maybe we will have some more difficulties with that, but I'm not sure.
Yeah, we are finally seeing presentation from Igor. Pretty nice. Igor, please try to say something. Your microphone is muted.
Yes.
Oh, okay. So everything's fine. We can now start.
Well, maybe not that fine because I had to use Firefox still. For some stupid reason, my Chrome on Ubuntu doesn't allow me to share anything. And I also switched off my second laptop, so I won't have any notes. But yeah, let's try without them. So, okay. I guess you should now see the presentation full screen, right?
Yes, it's perfectly fine.
Okay, great. So thanks everyone for joining. Today I will give a short overview of what I call inverse integration with Tango. Let me just shortly introduce myself. The key points maybe is just that I'm a kernel developer of Tango since 2016. Basically, I'm within the Tango community since 2012. And in recent years, I'm really enthusiastic about reactive design and implementing reactive systems. So for you who might not know about Tango, it's just short things taken from their website. Basically, Tango-Controls is an open source framework for building a SCADA or distributed control systems. And they have a quite large community and also very rich ecosystem. And here I just wanted to say that there is so-called one of the core services of Tango is a database server, which to say minimal, it kind of implements service discovery thing within the Tango control. So if you have a lot of nodes which called Tango servers, and they want to communicate with each other and with the client, they all have to connect to the database. And the current implementation of the Tango database is strictly bound to MySQL. So you can't use Tango without the Tango database, and hence without MySQL database. And another part of the talk is about Magix. So what is Magix? I would say that it's kind of lightweight and compact middleware. And basically Magix stands for Magic Box, this green box in the very middle that connects all the, we call it upstream nodes or upstream systems. So for instance, be it the Tango, Apex, DOOCS, or whatever. And Magix allows us to easily integrate these things, thinking only about the messages and how they communicate rather about transport and low-level API stuff. And the whole project can be found following the link on GitHub in the right bottom corner. So let's talk about this inverse Tango integration and basically the general idea behind it. So typically, if we want to integrate something, we would integrate some kind of bridge or adapter or connector, and such thing already exists for Magix, called Tango connector. It's on GitHub, open source, and ready to use. Basically, what it does, it translates the Magix messages into the Tango API calls and sends the response back. But the downside here is that it's one direction communication. So we can easily talk from Magix to Tango, but not vice versa, because unfortunately there are not really a sustainable solution for pushing notifications from Tango to Magix. And to basically work around this problem and provide a more sustainable way for tools and APIs from Tango ecosystem to talk to Magix, we propose these two new components. So the first one is a virtual Tango host, which is basically an implementation of a Tango database server, but not bound to any backend whatsoever. It just mimics the API of Tango database. And another thing is a virtual Tango server. So all the core libraries, which obviously used by all the tools and everything in Tango, could talk to Magix, other Magix nodes directly through the Tango API. So basically, the idea is to have a Tango API front end to Magix. So let's talk a little bit about the virtual Tango hosting. Here on the left-hand side, we see an email diagram. It's quite a straightforward thing. We have a database class, which implements some essential methods and the properties of the Tango database. And from the outside, Tango sees it as its own database. And on the backend side, we have an abstraction, so database backend, with some in-memory backend implementation. Basically, this is backed with a kind of hash map that just provides the discovery for our services and for Tango. So Tango client can discover our virtual Tango service. Here on the right-hand side, there is just a code sample of implementation of such in-memory database backend. So it's extremely simple. We have a map and just do something with it. And in the lower right corner, there is an example of a client application that runs our virtual Tango host. And here I want to stress that basically, obviously, we can implement any database backend we want. So, for instance, be it a YAML file or MongoDB or PostgreSQL or whatever. And another pillar of the whole solution is the virtual Tango server. It's currently a work in progress, but still the idea is quite clear. Hopefully, we have this dynamic features in Tango. We can dynamically define attributes, commands, and pipes. These are entities of Tango servers just from in code. And the idea is basically for our virtual Tango servers, send some describe message to our downstream nodes. So, for instance, if we have some device implemented, or for instance, DOOCS, and it just will send then its description, saying, for instance, its name, attributes, commands, and so forth. Obviously, there is some communication protocol between them via Magix, for instance. And what then virtual Tango server does, it creates this dynamic attributes commands, and implementation of such, for instance, command could look like this. So basically, it's just you see my mouse point, I guess.
Yes.
Okay. So we have a move command. We want to move some motor, and then there is a single line. So we broadcast to the Magix a specific message with some fields set, and just wait for the response. And now I would like to show you some demo. It's based on the project we are doing in collaboration with Alexander and Victoria and Olga Merkulova to control the spectrometer motors. They're basically some hardware. And let me just switch to my desktop. Here I have a Raspberry Pi with deployed micro Kubernetes on it, with all the nodes and ports required for simulation of the real motors. And there is also a web client, and you see here also this Tango host and Tango server. So the web client is quite straightforward. It looks like this. So basically, we have some motors. We can move them. This is in simulation, so it doesn't move any real hardware. And we also have this so-called Jive thing. This is a native application from Tango ecosystem. So this, with this, you can browse your devices. So, for instance, in our case, there are two motor controllers connected to multiple motors. And for instance, if we want to test this one, Jive provides us with this nice panel, and we can say, let me just move it here. We can say that, for instance, we want to move first motor to some position. You see it's updated. So we can use native Tango tools, and also we can use native Tango API. So for instance, here's a small test which creates a proxy to our virtual Tango server running on a Raspberry Pi, and then we will send this multiple move commands in a row. And here you will be able to see an update from the device, which is actually it's this port. It's a Python code that runs, Kubernetes, and eventually, if it's connected to the real hardware, it will move the real hardware. Okay, that's probably it with the demo. So further challenges. There are some limitations in the Tango design, as all the devices must be defined in the Tango database beforehand, before you can use any client can use it. So therefore, we have to think about some, let's say, static database deployment or dynamic, where we want that our nodes dynamically register themselves in the database. So these things has to be considered. Or we can, if we use a dynamic deployment, there is also a thing with continuous discovery, because currently there is basically, if not Tango node is pop up, so Tango server starts, and it's not defined as a database, it just reports an error and crashes. And that's basically not the behavior we want to for, let's say, our dynamic services. And there is also consideration about being this server as a single process thing, where all the devices are just threads, or it has to be multiple process thing, and then we can distribute them between different physical nodes. And of course, there are some questions about orchestration, traffic control, and so on. Hopefully, the Magix architecture allows us to easily address all these challenges, but just fiddling with the messages. Like, for instance, when Tango server just asks all other nodes to describe themselves, and then exports it to the outside Tango world. And yeah, so here's a link to the RFCs, and basically that's it. Any questions?
Okay, thank you very much. Nice talk. Are there any questions? While people thinking, Sven have a question. Yes, Sven?
I have a question on your slide number 5, Igor. Yeah, thanks a lot for this talk. And also for the live demonstration. Live demonstrations are always a nightmare, because Murphy is always everywhere. There you mentioned, so graphical user interface, it's clear, TIN is clear, DOOCS is clear, but then you have AI and ML, so machine learning, and how do they connect to Magix?
As any other service or via messages, so there should be some kind of a connector that translates what they want, or the API calls into the Magix messages, and then Magix sends them around and reroutes the responses back to that component.
Yeah, we actually have a working demo of this strategy, not actual machine learning, but processing and converting messages on just as they arrive. And our partners from industry, from Davide Electrics, are already having very similar concept in production. They do not use Magix or our own platform controls kit, which is for devices, but since we are consulting them, they introduced very similar concept, and they're using it right now. So yes, in this reactive approach, it's very easy to add any online processing as well.
Yeah, cool. Yeah, thank you.
And what is important, you do not need to wait for it. You get the message, and that you get spend any time working on this message, and you will get result as soon as it is processed.
And this will be in JSON format.
Whatever. Actually, we have not right now. We have not introduced binary in this message passing, and I think we will not use it directly. So the current idea is that each participant of this communication will have additional type of message which says that I have a binary message, large binary message, and a tag, and you can, anyone who wants to download this message need to get a additional request and download it. It will save us from moving a lot of duplicating large binary data through the loop.
Yeah, maybe I would just add that this thing about Magix is more like establishing communication protocols. I mean, the communication when each node defines what it wants to tell to other nodes and vice versa, while the real sending data around is something that is out of the scope of this thing. So I maybe rephrase what Alexander just said, that, for instance, via Magix, we will send a message with the address, and then all the interested nodes just attach to that address and download all the binary data they want.
We actually plan to add it quite soon to Controls Kit, which is a simple implementation of ideas. Controls Kit is not a part of Tango or DOOCS. It's a separate, very, very lightweight implementation of device server, which is not attached to any industrial control system, but has a first-class support for asynchronous communication and already has a nice interface with the Magix and with different protocols. We implement ZeroMQ, RSocket with both WebSocket and TCP, and direct HTTP and SSE connection. So, and we plan to add it later. For example, if we want to use it for detector data, not only for slow control, but it's not implemented right now. But we know how to do it.
Yeah, thanks a lot.
Are there any other questions? Okay, then maybe I have a short remark. When you said that it's a problem to dynamically load properties, I hadn't expected it, because we've researched the similar capability for DOOCS, and it seems to be, we did not implement it, but it seems to be more or less straightforward, because we can add dynamic properties there. So when we create device, it is blank, it does not have any properties. And then we send a request via Magix to request a list of available properties, and then they are added. Are there any principal problems on this path?
With Tango, no, it's more or less works the same way. The only problem is resources to do it. And yeah, basically that's it. I mean, there might be some issues with the Tango database and how to manage really multiple devices, but the idea is as you described it. So we have some virtual Tango server, which is just an empty server. Then it sends a request just
I think
through Magix to everyone, and then anyone who wants to be exported through the interface to the Tango ecosystem, they just send a response describing what attributes and what commands they want to export. And then this empty virtual Tango server creates all these attributes and commands dynamically. And then it's available through the Tango ecosystem.
I think it's a little bit simpler in DOOCS because it does not have the same configuration database as in Tango. It's configured mostly locally.
Yeah, could be.
Yeah, okay. Okay, thank you very much. Are there any other questions? I do not see any other people wanting to ask questions. Okay, let me then summarize. It went much faster than I thought, and I think that it was last year we together made a lot of progress in this regard, and the solutions we have right now seems to be close to be fully applied to specific problems, and even applied if we talk about this motto thing, Victoria's project. So I hope we will keep the tempo and make it all available to groups working with the hardware soon. Okay, I still don't see any questions, so I think that's it for today. Thank you very much, everyone, for coming, and for especially for Sven for asking very good questions, and of course for Vasily and for Igor. See you next time when we have some more.
Yeah, have a nice day, and thanks a lot.
Yeah, thank you. Bye.
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 Thank you.